Thanks everyone for tuning into Coding Talks. Myself Vishnu Vijay. I am a .NET developer and cloud architect from Thiruvananthapuram, Kerala state. In this episode, I like to talk about the containers and some of the benefits of containers. We will discuss some of the services offered by different cloud vendors like AWS, Azure and GCP. Also, we'll look into some of the reasons why enterprises prefer containers over serverless. Then finally we will be discussing about some of the development considerations as well as the different Kubernetes platforms like self-hosted and managed Kubernetes, and we'll talk all about the containers in general specifically in this episode. This is not focused on any specific cloud vendors, but we will be discussing the container services from the leading cloud vendors like AWS, Azure and GCP. So we'll start with that one. So if someone asks me what is containers, I would like to say it's a kind of an application packaging where you include everything required for running that application. So this includes the runtime, the application plus its dependencies, so that you form like a complete package. We will call that as an immutable container, shipping similar to the shipping container. Then you build that using your favorite development code editor. I personally use Visual Studio for creating the Docker packaging and all container packaging. So usually Visual Studio, if you are using Visual Studio Professional or community version, there is an option to create Docker along while creating the application. It will automatically create a Docker file which includes lines of code to include the required base image, the application dependencies and an entry point, so that you can have a build based on this, which is called the container build image, and then finally you can store that somewhere in the cloud, which also is called the container registry services. It's just like a kind of a repository where you store the code. So this is not code, but it's a kind of an artifact, a build artifact, which is the container image. In the world of containers, that's called the container image. So this image is actually immutable, and you can deploy that in various environments, whether it's your development environment, the integration QA or live, wherever you want to deploy that, you can have that. Not only you can deploy that, first of all it solves the problems of dependencies. Previously, earlier days, developers used to deploy an application onto some server, but they have to think a lot about the different dependencies that should be in place before running that application. Otherwise the application will break. So they need to install it in advance, or needs to ensure that everything is there in place. Previous days, the .NET the application were developed using .NET SDKs like a 4.6, and we should ensure that the server where we are hosting should have that compatible runtime installed. Otherwise the application cannot perform. So this is a problem with the dependencies, and in the case of .NET, the version SDK, like I mentioned, it is much simpler. You can simply install that on the server. But when it comes to complex application dependencies, then managing all the dependencies in advance will be challenging. So the container is a kind of a way where everything will be defined at once during the development itself in the form of container file. You can add that later also. If you have an application, a Java application, and if you want to containerize that, you can add later by simply adding a Docker file. There should be some specific way you have to define that file, and once that is there, Using Docker desktop, Docker or Portman, you can build that application which will form an image. That image is immutable and you can push that to some repository, which in container terminology it is called the registries. Various registries are available. If you have cloud environment, you can have their own registries. In the case of Azure, it will be like Azure Container Registry, and also Amazon also have a similar registry in place. In addition to that, there are other public registries also, like the Docker Hub. So depending upon the specific requirement, you will be hosting that, will be borrowing some registry services from either of these different cloud providers, and then you will be storing your image in those there. The reason why you are storing that image there is that this is a kind of an artifact which you will be further deployed into different environments. So how you differentiate the different environments? So basically the configuration for the container application should be read from the environment variable. So while developing the application, we developers should ensure that the application should read the configuration from the environment setting. So this is easy in the case of .NET, where you can simply add a line of code to read it from the environment variables. By default, your .NET Core application will read the value from the application app settings file, and if you have an environment settings also in place, then it will give preference to that one. So that means in your local system you can have an environment variable which will be read by your application, and on the other different environments, respective environment variables or keys will be set up by the release deployment scripts. Ops will be doing that, and then your application, the same application which you have on the registry, will be performing similar in all the different systems. The benefit of this approach is that you can have a standardization in place. So your application will work effectively in your local system, in your laptop. In laptop, usually I prefer Portman. Some developers will be using Docker desktop. Docker desktop has some challenges running inside the enterprise systems, especially if you have a lot of employees in your enterprise, then you would need to pay for that. It's not a free edition. It was free before, but nowadays they made it a kind of a paid subscription model. So Portman is actually free, and so because of its open source free mode, then most of the, and it's also compatible with enterprises as well. So most of the enterprises are using Portman. So either of these tools, either Docker desktop or Portman, can be used to build and test your application locally. And on the cloud environment, you can pull it from the container registry, and then you can deploy that to any compatible platforms. And now you might be wondering why we're doing like this. One advantage I already mentioned, that you can have a standardized code with its dependencies embedded or packaged as a container. So that means everything required for running your application is in place within that container image itself. With just that container image, any compatible runtime can spin up your application. No extra dependencies are required. Again, you need to think a bit about different configuration considerations there. You need to set the correct the configuration values as environment variables, or there is another one approach also where your application can read the secrets and others from some form of key vault services available in the cloud, like the AWS key vault or Azure key vault. That's also a different approach, but usually I have seen in many cases where it's read from an environment variable, we need to make sure that the environment variables are done in a secured way so that it remains safe. But that is also a possibility. Otherwise, you can go with your key settings stored in the key vault. So here you see like a kind of a standardization you can achieve with the help of containers. And if your application has a lot of complex dependencies and all, which is not possible with the serverless systems, then this can be achieved with the help of containers. Another benefit I usually see in the case of the containers, especially the organization go with containers, is that even if you have a legacy application which was developed using some form of older framework, still you can make that application as a containerized package, and then you can deploy on any container compatible cloud platforms. That means in some form, even as in a basic form, you are converting or you are moving your application from your on-premise systems to cloud. So the easiest way to have something to move that to cloud is actually the containerization. That's benefits you will get from that. Then usually enterprises start with lifting application from on-premise like this, and then they will deploy that onto the cloud. Then they will improve it. Usually improvement can be done in terms of modularizing your application. The more modular your application is, the better it can be managed and deployed independently. So the way to achieve this is through a kind of a service-oriented architecture, or most commonly in container terminology, the microservices form of architecture is very much related to. So this is kind of a microservices is kind of an architecture where you split your application based on horizontal. You split your application horizontally based on the level of services it provides. So if you think about a monolith, and if you horizontally split it based on different domains, payment can be one domain, then cart service can be another domain, then the display of items or the customer interaction can be another one domain. So each of these domain can be splitted into different components, forming it as an independent microservice, and a collection of such microservices interact with each other through a network in some form. It can be AP, or it can be some form of gRPC or GraphQL, or whatever way it's interact with each other. That way you can form microservices architecture, and this containers is ideal for deploying such kind of microservices architecture. Microservices is not required for every application. Even when I say that it's a kind of a newest form of deployment, still the de facto standard of every application can be a monolith, which can be then splitted into different microservices. So if you're sure that your application has scope for scalability and improvability, then can go ahead with the microservice architecture. And this containers is ideally suitable for microservices architecture, because each of your microservices can be deployed independently, scaled independently to thousands of instances with the help of containers. It can be easily achieved with the help of containers. You could have achieved the same with the help of a virtual machine as well, but in the case of virtual machine, as you might already familiar, it's actually costly and difficult to maintain. You can create thousands of virtual machines, or you can have multiple virtual machines inside on machine in the form of virtualization, but virtual machines is a bit kind of a heavy weight. So compared to that, containers are very lightweight, and with the help of modern cloud systems, you can simply deploy a container package onto cloud and you can spin it up easily without bothering anything about the infrastructure, because those cloud system can do everything for you. Then some of the use cases, we will discuss some of the use cases. On use cases I already mentioned, like the microservices, then some microservice, and we already also discussed about the case where organization took their native legacy applications and moved that into the cloud by lift and shift in the form of containerizing that. Then batch processing also can be a use case, where there are cases where enterprises read the data from one system, then it will do a kind of an ETL job, like extract, transform and load into different other systems. So this one usually in the case of a monolith service, each all of these ETL tasks will be running as a single unit, and it is difficult to scale it and also difficult to maintain. In the case of containers, you can have each of the different parts as a different service and kind of a microservice, and you can scale it out to hundreds of instances so that the batch processing can be done quickly. You can also have a kind of a form of parallel processing, running multiple containers and process it simultaneously. Then more faster batch processing can be achieved. Then some organization use the containers for scaling the machine learning models, because the machine learning models used for training and inference, if they run close to the data sources on any platform with containers, it can be scaled much better. Now again, the same thing as I defined on the initial, like the when you make an application containerize, you are making it compatible with the cloud, and that also ensures a kind of a standardization where you can run that application anywhere consistently. It means if it runs properly on your local system, you can ensure that it will be running on the whatever cloud platforms also. So that way a consistency can be ensured in that case. So why then again why then organization go for containers over serverless? If you look into the modern trend, serverless is a preferred approach for deploying the application, provided if your application has been altered or developed in such a way to run in a kind of a serverless fashion. But again, some of the applications needs control over the environment. So in that case, containers are preferred. Then if you want to have some predictable performance, consistent performance, containers can offer it. It doesn't mean like serverless does not offer predictable performance. The scalability can be achieved more in the case of serverless, but in some cases containers can offer predictable performance compared to serverless function, especially in the case of scenarios where there shouldn't be any latency or you need ultra fast responses. Then containers can be helpful. If you look into the concept of serverless systems are usually spin up on demand. Whenever you need something, you achieve that with the help of a lambda function, and AWS will spin up a lambda on behalf of you depending upon your requirements. So it can be an event, or maybe a insertion of a queue message, or maybe an addition of a blob in S3. AWS can spin up a lambda function which can take a few seconds. So there will be a kind of a cold start scenario. It won't be, again, don't confuse here with that it might take more than 2 or 3 minutes, which many developers have misunderstanding. Usually there will be some milliseconds latency, And usually if your application is done in such a way that those milliseconds latencies are acceptable, then serverless would be a better preference. And also in the serverless itself, we are not going much into serverless, but again in the case of serverless itself, there are ways by which using managed provision you can provision a specific service in advance so that it will always remain active. And there are other ways also to make to avoid the cold start scenarios. But still again there are some cases where again these all things may not work as expected with the serverless. In that cases the containers can offer more predictable performance. Now there are some cases where organizations require complex specialized environments, especially for running long running tasks. So serverless are specifically benefit for you when you require those services on demand. So if you think that okay, one event might happen once in a week or once in a month, then serverless can be a better choice, because serverless, in the cost structure of the serverless system, says that you will be paying only when you actually need that. But certain other cases, you organization might have some applications running continuously, or it can be some kind of a long running process. In that case, then containers would be better preferred than the serverless applications. Then for stateful applications, usually serverless is typically stateless, but containers can maintain state for some more time. Some applications might require that, especially if it needs to hold some information in memory and needs to process that for that particular run or for that instance. Then it can be achieved easily with the containers than the serverless one. Then networking related capabilities. Containers provide more robust networking options, like long-lived connections. In the serverless world, you're actually spinning up the serverless on demand, so there won't be that much long-lived connections in the case of serverless. Then the predictability of cost. While the serverless systems offer pay-as-you-go model, sometimes when serverless can become a problem when it scale indefinitely and in an unpredictable state. So it will cost also much high. In that case, if you manage those scenarios with containers, you can have a predictable cost models for your application. So that's one of the reason why the certain organizations still prefer the containers over serverless. Then another one is vendor locking. So if you have a serverless set of architecture, that essentially means that you have developed that application considering that specific cloud vendor in mind. If you developed for AWS Lambda, then that means you have developed the system for that AWS Lambda. If you want to run that same on to some other providers like Azure or maybe GCP, then if you develop that in serverless, it's difficult to achieve. But at the same time, it can be achieved in some way, but there are ways for achieving that, but it's quite not easy as in the case of the containers. In containers, if you have an image, you can run it anywhere. So it can be run on your AWS cloud, or if you want to have what we call, there's a term called multi providers, multi-cloud providers. So for very high availability scenarios, some organizations have multiple providers. They can have Azure or AWS, and if you want to run your application in two different providers itself, not environment, two different providers like Azure or GCP or AWS or whatever, then that can be achieved with the help of the containers most effectively. So this is particular in the case of multi-cloud scenarios. Multi-cloud is also a trend which is booming up. Usually high availability can be achieved with the help of multi-region or maybe multiple. By default it has a kind of availability, high availability in the form of multi availability zones by default. But again, if you want to achieve more availability for your application, usually in the cloud world you achieve that by having multi-region deployments. That means your application will be running in 2 different regions. It can be North Europe and West Europe. So that means in case if cloud systems goes down in one region, it can be still served from another region behind a load balancer. This is in the case of very high available applications like example Facebook or Twitter, where they do not they usually shouldn't have a downtime at any time. So in that very high available scenarios, or maybe in the case of some health care management systems or traffic management system where high availability is a very critical concern, then very high availability can be achieved using the multi-region deployments within a single cloud. But that same high availability can be further extended with the help of the multi-cloud data centers, where you can have the same availability in different cloud vendors like Azure and AWS. Cost will also be high in that case. So in that case, containers would be preferred over serverless, because if you go with serverless models in that way, you have to develop in 2 different ways. There are ways to still standardize that even in serverless world, which is a trend coming up, which we will discuss in another episode. But with containers, it can be achieved very easily. So that's some of the overview. Then another one main area where developers or maybe those who are new to development may be a bit confused is they always associate the terms Kubernetes with the containerization. Whenever containerization comes into picture, the role of or the concepts of AKS or EKS, Kubernetes services, some form of managed Kubernetes services, or some sort of orchestration also comes in mind. But keep in mind that Kubernetes is not an absolute requirement for running container application on the cloud, whether it is Azure, AWS or GCP. But it has a popular choice because it has some powerful orchestration capabilities. So that's why we should go for Kubernetes is that in certain cases where if you have a complex microservice architecture which includes hundreds of components, deploying each one of these in different container platforms and managing that would be quite challenging for you. In that case, the microservice, the Kubernetes can greatly help. So Kubernetes is kind of an orchestrator on top of the containers, which is developed by Google, and later they donated that to the Cloud Native Foundation. Now they are managing the releases of Kubernetes. And what happens is usually all the cloud providers, AWS, Azure and GCP, have added the Kubernetes on top of their cloud services, making it a kind of a managed services. One of the problem with Kubernetes is that it requires special expertise to manage that, especially if you are hosting Kubernetes on your data centers. Kubernetes, the main importance of Kubernetes comes into play when you have a cluster which spans multiple machines, and that clustering and other things can be quite difficult to achieve in a self-hosted data centers, which can be easily can have in a cloud environments. In Azure or AWS, you can simply declaratively mention to the cloud provider that I need an AKS cluster with this specific configuration, and those cloud providers will do that on behalf for you. But what happens when you manage that locally is that it requires a lot of infrastructure management, but there are some organizations which still require the case of what we called the for the audit purpose and compliance purpose. They have to keep the data somewhere in their data center itself, and still they want to manage a lot of microservices. Then they go ahead with a kind of Kubernetes self-hosted. But again, as these the cloud services become more popular, the managed Kubernetes is what majority of the organization. And in case if they want to have some form of the Kubernetes on cloud, these cloud providers also provide some kind of on-premise Kubernetes, which is called the AKS Anywhere, AKS Hybrid. That's from the Azure or AWS, EKS Anywhere. That means using their stack, you can develop you can create a Kubernetes cluster on a set of machines, and can be managed with the help of these cloud vendors dashboard and all. So they will do some sort of infrastructure management for you even in the self-hosted data centers, but it's not that much hard as that when it comes to managing it individually in the data centers. So that's very rarely, mainly most of the organization go ahead with having some kind of managed Kubernetes services. And also like I mentioned earlier, even though many people associate containers with this Kubernetes, actually it's not required, because nowadays in cloud there are different services available which can scale indefinitely, and those will be managed by the cloud vendors itself. So you can have something like ECS which can scale to multiple instances. So in that case you don't require the Kubernetes at all. So that means you can still run a containerized application in cloud without having a Kubernetes. The role of Kubernetes comes into play when you want to have more manageability and orchestration with multiple hundreds of components, microservices that can be easily achieved with the Kubernetes. There will be a separate episode coming up soon where I will talk or discuss about the different Kubernetes terminologies and all. Which can be quite helpful when you try to work with any of these Kubernetes platforms. Then, so again, I already mentioned that in the first beginning of the episode, how you can easily containerize an application. You can simply add a Docker file, and if you're a .NET developer, I usually do what is like simply I let the editor Visual Studio Professional to create a Docker file for me. So depending upon what kind of framework that I choose, usually nowadays I usually choose the latest version of .NET Core, which can be run on any platform. So while creating the application itself, there is a provision to create a Docker file, which means your application is containerized. And if you install the Docker desktop, provided if your organization has license, or if your organization number of employees are below a certain level, then you can have Docker desktop. Then if you have the Docker desktop installed on your system, you can debug the Docker application or containerized application from Visual Studio itself. You can also achieve the same from the Visual Studio Code as well. You can have some form of containerization with the help of Visual Studio Code, but debugging is more possible with the help of Docker desktop installed on your system, and also Visual Studio Professional will be required. There are cases where you might not require to debug locally from within the Docker itself, because your application you can independently test it, and in case if you want to test it, you can commit that code to some repository, and from there if you have set some continuous integration, continuous deployment, build systems, then automatically it will create a kind of a package in the container build image in the registry, and from there you can deploy that to any compatible platforms in your development environment and test it. If you're sure that your application is modular and do only a specific set of functionality, then individually testing that within the Visual Studio is also fine. Because what happens in the Dockerization is actually, or containerization is simply, it's a kind of a deployment strategy, or it's kind of a packaging. So usually for every debugging you don't need to run that inside a container itself, but once you develop an application, or at least in some stages, you can test it inside a Docker desktop, or maybe Podman is also another one, free open source library, open source service, where you can install that on any platform. Some extra it's not easier to set up. You need to understand and you need to have some dependencies like WSL in advance, especially on Windows system, to run the Podman. If you configure that correctly, then you can again build a container image, and then finally push that into a container registry, and you can, from there you can pull it through the Podman, and you can run it and test it locally as well. So I usually go with a kind of a mixed approach. Sometimes I debug right away from the Visual Studio itself. Sometimes I usually debug on after building an image and push it on to the registry, and then I debug that on the different environments. That's another one. Then securing the container registry is also important. So if you look into the default registry, it would be usually public, but enterprises might require their container registry to store with container registry to be private within a virtual private network, so that the access to those registry will be restricted. But when it comes to Azure, what I usually noticed is that if you have a registry and if you try to make it private, then you would need to do a lot of end up in a lot of problems, especially if your external systems like Azure DevOps tries to access that. There are ways to resolve that, but usually you need to have some sort of extra configurations if you make your container registry private. So usually public registry is not recommended in enterprise scenarios, but if you want to have it private, then would need to do a lot of settings related to VPC and other factors. We are not going deep into that. There is a document in Microsoft which specifically explains that details there. Then let's look at some of the different services that are provided by different cloud vendors. So we'll start off with the I'll start with the AWS container services. So again, this is not Kubernetes, especially for many people, when it comes to containers, as I said before, the Kubernetes is something that comes to mind. But it's actually not required, and I could see from the different case studies from the different cloud vendors, that Kubernetes is nowadays getting replaced by different serverless services like AWS Fargate, where you can have the same sort of serverless scalability and manageability with the AWS Fargate. When you think about the serverless concept, that means you don't have to worry, or there is very least worry about the the manageable aspects of the platform. So when it comes to AWS Fargate, the benefit is that everything related to the patching, the scalability, then the security, logging, and other aspects will be handled by the corresponding platform itself. So if you have one or two container or components that needs to be run on the cloud, then it can be the AWS Fargate also can be a choice. You can have multiple components, more than that components also in the AWS Fargate, but you need to have some sort of a framework like a serverless framework or serverless access model script in using the AWS to deploy that, and especially the manageable, when it comes to the manageable aspect, it will be much easier. So if you look into the AWS container services, we'll now discuss about the different container services that are provided by different cloud vendors. So if you look into the AWS container services, the Amazon Elastic Kubernetes services, or what we call EKS. EKS is a kind of a built on the top of Kubernetes services. All the cloud providers have taken the Kubernetes services, which is provided by the cloud native, and they are added on top of that to reduce the different manageable aspects of these Kubernetes service. So this is kind of a managed Kubernetes services on the cloud. So a managed service you can run on AWS with the help of EKS, and you don't have to worry about installating, operating, and maintaining the Kubernetes control plane or nodes. But usually there will be charge associated with the managing the node plus the clusters. But the benefit you are getting is you don't need to install or operate or maintain your own Kubernetes control plane or infrastructure. Mainly the infrastructure management will be much lesser in this case. Then if you want to have some more control over the container, then some organizations are using EC2 with containers, which is a bit costly, but that can also be done. And some organizations are also using EC2 with Kubernetes cluster. EC2 with the different Kubernetes cluster, so that it can provide scalability. Then AWS Fargate, we discussed that already, which is a kind of a serverless compute engine for containers, and this can work in conjunction with the other container services within the AWS, like the Amazon Elastic Container Service, as well as the Amazon Elastic Kubernetes services. Then Red Hat OpenShift on AWS, that is also built on top of the Kubernetes platform. If you look into the Red Hat OpenShift, you can see they do have all the different components for different parts of the development. So if you have a code, you can have the repository inside the Red Hat OpenShift. So OpenShift is a complete environment by itself, where you have the repository, the pipelines, build pipelines and release pipelines, and everything for running your application, the containers, the Kubernetes, the container runtime platforms, the cron job, the schedulers, everything are included within the Red Hat OpenShift service. So Red Hat OpenShift service will be available either from the Red Hat or from the different cloud vendors. Back in the August 2023, I attended a conference on the Red Hat here in Trivandrum, Red Hat OpenShift service, where we played with the different Red Hat OpenShift services. Usually I found that environment quite easy, because everything is there within that environment itself. Everything, whether it is related to build, deployment, code repository, and even a code repository means you can have the code, the actual code repository, like the GitHub like code repository, plus the container registry is also available, and the name of that service within the OpenShift is called the COI. So everything is included there, which can be accessible from the dashboard itself. So it's quite easier, and a pipeline is there. Then if you want to scale an application or scale down, that provision is also there. So this is like a complete package built on top of the Kubernetes platform. Then which one should you choose? That is a bit challenging for someone. So if your application has the scope for scalability, and if you expect that your application would need complex orchestration, then it would be recommended to go ahead with the Amazon EKS service, Elastic Kubernetes service. But if you need some ETL jobs to run as a containers, or maybe some set of containers which you can independently manage and which doesn't require that much level of features as that of an EKS, then AWS Fargate and ECS are better options in AWS. So Fargate is a kind of a serverless, whereas ECS is not exactly serverless, but it's a elastic container service, similar to the EKS, but not that much feature as the EKS. So Amazon has the main service called the EKS, which is the pure elastic Kubernetes service, which they built on the cloud. And in addition to that, there is a service called the ECS, or Elastic Container Service, which is an Amazon version of the AWS version of the container services, which also has its own capability, but it's not that extensive or feature rich as Elastic Kubernetes services. But majority of the cases, ECS or AWS Fargate would be enough. Then if you have some kind of a association with Red Hat, or if you want to move that to Red Hat, then Red Hat OpenShift service is also fine. Then if you look into the Azure Container Services, again the same applies there, similar to the AWS. Like the Azure Kubernetes Services is the main one, which is built on top of Kubernetes services. It provides the same capabilities as Kubernetes, but this is managed, so you don't have to worry anything about the managing the infrastructure. You can declaratively create clusters, and you can scale it infinitely. Then Azure Container Apps is also a Azure version of the Kubernetes. So it's a powerful platform exactly based on the Kubernetes. Then sometimes again, just like the AWS ECS, sometimes our organization don't require that much level of orchestration or complex infrastructure as that of Kubernetes, and in that case you can go ahead with the Azure Container Apps. And in case if you want to run some scenarios where you want to have some individual containers without managing VMs or cluster, then or if you want to have some short-lived task which you want to run on, or some microservices task to run, then ACI container instance, which is the very basic service, container instance service in the Azure, which can also be considered. If you look into Azure versus AWS, you cannot see any serverless serverless container services within the Azure platform. Azure has one called Azure Container Instances, where you can run independent container instances, but it would require some kind of an orchestration, like either from the logic app or some other Azure function to connect or run that service, because it's by its own nature, the Azure Container Instances does not have any provision like the scheduling the jobs or anything. So that means it requires some other service like an Azure Logic App or something to make it a kind of a serverless fashion. You can have that serverless container capability within the Azure as well, but the problem is that there you would need to have two services. Maybe more services. You would also need a queue or some other compatible source service as well, to correctly make it serverless. Then if you go into the GCP world, they are also similar, like the GKE with the Kubernetes version. Then Cloud Run is there, which is the similar to the ACI and the ECS, that which we ACI and the AWS Fargate, which we have seen. So these are kind of a stateless container run. Then GCP also has the associated registry services and individual services, which can help with the containerization of application. Then finally, before we wrapping up, we will see how to operate these containers, or how containers work from an operational perspective. So when it comes to operational perspective, majority of the cloud vendors have integration with their own logging mechanisms. In the case of Azure, by default, it can log that into the Azure Monitor, which is a consolidated space for having all kinds of logs. There you can set up alerts and everything. Similarly, in the case of AWS, they have the CloudWatch container insights, which can be used for monitoring the container application. What it does is it collects, aggregates, and summarizes metrics from the different containers. So containers can be running on Amazon ECS or Amazon Elastic EKS Kubernetes services, or even it can be run inside AWS EC2 mode or Fargate. So all the different container services can have integration with the logging mechanism in the cloud. So what you benefit from using the container services from the cloud is that you will get all these integration, especially when it comes to operational perspective. The monitoring is a critical part of the operations jobs. So there the having a rich set of integration with the some logging mechanism like CloudWatch or application insights or Azure Monitor container insights will be greatly benefited. Similarly, in GCP also there is a Google Cloud Monitoring, which also the same concept, like it connects with the different cloud container services offered by GCP. And in addition to that, by having these services from the cloud, you will also get integration to other services as well. Say for example, if you use AWS Fargate, you can have the serverless container running on AWS. Plus, if you want to have some integration with the other storage mechanism or anything, you can utilize the S3 storage mechanism. Similarly, if you want to use a queue mechanism, there is a queue mechanism also in the AWS, which is the Amazon queue service, SQS, which can be used for storing the different events which can be consumed by your AWS Fargate or ECS. So similar way, there are rich integrations offered by different cloud vendors. So that means in the older days, when you want to achieve containerization, if you had the VMs, nowadays usually by simply adding a Docker file and associating the different build and deployment pipelines and storing the build images onto the registry, you can scale the containers indefinitely. And if you have complex orchestration capabilities required for your application, you can resort to something like a managed cloud provider service like EKS or AWS EKS or Azure AKS. Then another one benefit that you would get from having this kind of service is everything related to the patching of the service, like the updating the service, and everything will be taken care of by the cloud vendors itself. So that means it's much easier for you to focus on the application logic, and you will get a scalable application that can scale independently and which would be cost effective as well. If you want to develop a serverless application, you would have to think about some consideration, but that much consideration is not, or that much thought is not required in the case of containerizing an application. You can simply improve the containerized application once you shifted that to the cloud. But coming to the serverless world, you have to a bit of thought about the different ways by which you can make it an effective serverless application. Otherwise, the serverless may not be a great fit. So in that case, containers would really will be helpful. So that's an overview. Thanks everyone for listening this podcast. There will be one more session or podcast coming up related to the Kubernetes in specific, especially the Kubernetes platform. Usually, those who have used the Kubernetes from the cloud, they usually can use the service in a kind of a declarative fashion, where they can have some manifest and the cloud service will do that for behalf of you. So but still having some idea about the different concepts in the Kubernetes worlds, like the persistent storage, then the pods and other things will be definitely helpful, especially once you have some Kubernetes services running in the cloud. It would be helpful though if you understand those terms, so that it can help in application debugging and maintenance, especially from a maintenance perspective. Development side, usually it will be good to know, but still it's more applicable from the perspective of the operational level and infrastructure management level. Infrastructure management also, again, you don't have to much bother in the case of cloud, because everything once you declared that in the manifest, it will be created automatically for you. But the other areas, like how to dig into the Kubernetes using the Kubernetes ecosystem, using the kubectl command and all, how to identify what all pods are running, whether any failure happened or not. All those things will become relevant when you actually deploy an application even in managed cloud, and having that knowledge will be really helpful. So I will be having one session on that in the next episode. So thanks everyone. Thanks everyone once again for tuning into the podcast. Have a great day or evening or night from wherever you are listening this podcast.